Okay, gentlemen, I've been wanting to shoot this video for a long time. And my good friend Lee in Hawaii, this is for you, buddy. First off, let me say, if you enjoy this video or you learn something from it, you might want to think about coming down here and joining the team on Patreon. Come kick a little support to the team, you guys. That way we can keep doing fun educational videos like this. This is my job. Come help me teach more. I would love to do it, and I'm going to keep doing it as long as I got your guys' support through patreon.com. I don't want to go get sponsorship. I don't want to do a whole bunch of commercials on the YouTube videos. I'd like to keep this real grassroots radio. That you get access to the YouTube videos 48 hours, that's 2 full days before everybody else on YouTube, and you get your name at the end of the video to say, hey, I help support. Or come throw support, and you don't have to have your name up there. Just don't add your name to the list when you come join. Okay. Now that we got the sales pitch out of the way, let's get down to the fun bit. Whew. Okay. Today we're here to talk about vacuum variable feed points. You say, well, what is that? I say it to people all the time. I say, well, man, you're having problems with your gamma match. Why don't you just put up a vacuum variable? It'll handle 7,000 billion times more horsepower than your gamma match. And then I start to explain it to them, and they go, they don't get it. And I understand. I understand. This is a gamma rod, gamma feed point. And all this is a variable capacitor. Okay. First off, with gamma rods like this, they say this one's rated to 10,000 watts. In my experience, it's rated to 5,000 watts-ish. And what I mean by that, I want to be very specific about this, is that when this thing is new and it is virgin and there's no dirt on anything and there's no moisture on anything, I'm sure the insulating properties of this nylon that's in here will hold will hold 10,000 watts. I wouldn't trust it, but it will hold 10,000 watts. Now, the main difference between this and like your gamma rod that you have on your, let's say, Moonraker 4, Lightning, Star Gun, whatever, is that it's got an SO239 connector here. All that SO239 connector does is attach to this bracket, which is attaches to the boom. And then you have your shorting bar, which sits out here roughly about halfway, right? That goes up to your driven element. It attaches to this bracket, and then the center pin off the SO239 connector goes to this piece of tubing here. Well, let's take this apart. You have a hollow piece of tube. You have an insulator device, which is supposedly Teflon. They claim this is Teflon. This is not. This is nylon. A lot of these guys won't build with Teflon. It's not cost effective. This nylon is the Achilles heel of this system. Okay. I get probably 2 calls a week where the guy says, man, I got my 10,000 watt gamma match. I put it up a couple months ago. I just had a friend of mine, a really good friend of mine, Mr. M, over in Washington. He called me up and says, man, this is brand new. It's been up there 2 months. I put my 16 pill into it, and now my SWR is jumping all over the place. And it'll start out, and I'll have a low reflect, and all of a sudden, as I'm talking, it goes up and 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 up. Yep. I wish I would have saved the picture that I got from Brian Smith a million years ago. This is a million years ago. My good buddy Truck at Truck CB Sales. He got into building himself a beam at his old house. He had himself a gamma match like this, and he couldn't figure out where his reflect was coming from. He's like, man, it's something in my he changed all his coaxes, and everything. I kept telling him, I said, Brian, it's in your gamma match. It's in your gamma match. He's like, oh, I can look right at it. I can look right at it. I can see it. I can walk up to it. I mean, like when he turned his beam and put it down on his roof, you could walk right up to it and see it. And he's like, he goes, no, but I have such a great match when I run a lower power amplifier. I said, Brian, it's in your gamma match. He didn't want to listen. This went on for about 2.5 weeks. And then one day, randomly out of the blue, I get a picture of his gamma match sitting on top of his trash can. And from here back is black. Where this had gotten a little bit of water in it, and there was a little pinhole crack that was in the nylon, not virgin Teflon. And even if you get one with virgin Teflon, Teflon's an amazing thing. But once again, the heat, the outside, dirt, moisture, bad. A little tiny crack had formed in the thing. A little bit of water got in there. The RF jumped through that little piece of water, or little tiny moisture molecules, or just literally came rode up through that pinhole and arced over to the inside of his tube. The inside of the tube looked like somebody had taken a blowtorch to the inside of it. I wish I would have saved that picture, but I can't find it. Otherwise, I'd insert it here so you guys can know what I was talking about. The main difference between this and your Joe Gun, Star Gun, Moonraker, PL259 connector is that this has got an insulator on it that separates this tube from this bracket. So what you would do is you take your coax and you're going to pigtail it. You take the shield, go to the boom, take your center conductor, put an eyelet on it, and you bolt it onto here. This is about a 2500 watt. And remember, there's two forms of measurement. You got your peak and your average. So when you're talking to somebody on the phone, they'll say 2500 watts, but are they talking peak? Are they talking average? I wouldn't put more than about 2500 watts average through this thing, maybe 5000 watts max. This is a 10,000 watt gamma. Let's talk about how this actually, the principles of this. The idea is to be able to keep insulated value from the center conductor of this tube to the inner portion wall of this tube. If you have a pinhole crack that starts in this nylon, the RF does not give a shit. The RF has to try and stay on the outside of this tube. Oh babe, oh babe, oh babe. The RF has to try to stay on the outside of this tube, and it's got to ride the outside surface area to get back to this center conductor of this tube, the inner tube. If there is a crack that appears in the middle of this, it can jump right through and pinhole. So the reason I say that this is a 10,000 watt gamma, yes it is. When it's brand new, it's never been wet, and it's never seen moisture, it is possibly a 10,000 watt gamma. Either that be RMS or peak. In my opinion, this is a 5,000 watt, period, peak power gamma. Because if it's wet or it's got a hole in it, 5,000 watts is not going to have a very good successful time migrating through the nylon. So this is a mechanical motion where we slide, well actually this stays fixed. Oh babe, oh we're bottoming out on her, oh we're hitting the top end of it. This is a mechanical action, and all we're doing is adding capacitance, subtracting capacitance. We build with these all the time in the amplifier business. This is called a trombone, what people call trombones because it's brass. Okay, this is just a variable capacitor. And in here is a little thin piece of Teflon sheet. The guys at ICA make these, they make them by hand. Okay, they cut the sheet, they've got the knurling tool that folds over the edge and bells out the copper tube for us, or the brass tube. Piece of brass, Teflon, another piece of brass. Ground. Then we hook this up to our output, and we can vary our capacitance by moving this in and out. The idea behind putting a vacuum variable is that you're going to overcome all the downfalls of this, the pitfalls of this feed point. Now I could get into feed point and talk about feed points all day long. I am not the antenna whisperer. I don't want to be known as the antenna whisperer. Not interested in being known as the antenna whisperer. Could care less about being the antenna whisperer and feed points. And people are going to debate this till the end of time. If you feel that you need to go and debate this, come down here in the doobly-doos below. I'm going to leave the comments on, and you guys have fun tearing at each other. I could give a shit less. You're not going to get any comments out of me. You can tell me I'm stupid, fake, or whatever. Don't care. Put it in the doobly-doo below. Guess what? You guys are gonna have fun. It's all you, I'm out. I don't care. I'm here to explain how to make a vacuum variable feed point. Have fun, because there's no dark magic. Pick up an antenna handbook. I did, I read one, I understand. 2 or 3, 4 or 5 books on antennas. I still don't think I know everything, because you never can know it all. The whole point of removing this motion here, this mechanical motion, we're now going to replace it with a fixed tuning point. This is an ITT Jennings 5 through 300 picofarad, 7.5 kV, easy 7.5 kV vacuum tuner. My friend over there in Hawaii is going to put this on his current setup that he has now, but we are planning on later this year or the beginning of next year building him a demonstrously large system for over there. This will easily handle what he's got going on now and allow him a lot of room for expansion in the future. We'll come back to this. The vacuum variable sits here. Your coax attaches here, and this tube attaches here. Now, I'm going to say something that's going to make everybody freak out for a hot minute, but I want you to think about it. Think about it before you freak out. There is a front and a back, or a hot and a ground side of every vacuum variable on Earth. Hot is this side, or where your RF is at. Your ground is on this side. Think about how they're mounted, how they come into use, and how we use them. Like, you do not want to do this. Don't be stupid. Don't do this. This will fail on you. I've had it happen. What do you mean? Well, on some guys' setups, the only thing that they can get to is just right at this edge. They can't, it's real hard for them to reach out here. So there's going to be some guy out there that watches this and goes, I'm a rocket scientist. That's correct. You're smart. You're thinking. Instead of me having to reach all the way around to the outside of this tube to make my adjustment on my capacitance, I'll flip it around. Don't do it. Fight the urge. Fight the urge. Think about how this capacitor is set up in every amplifier and every other application that you've ever seen. Your device that you're wanting to tune to is on this side, and your ground coupling is on this side. Well, think about what's happening here. Ground coupling, fixed. Fixed, ground coupling. Hot, ground. I'm positive those aren't the right terms. Somebody in the doobly-doo is going to correct me. I'm cool with that. I'm willing to learn. This is the proper orientation for this cap and its installation. So, let's talk about variable capacitance and let's prove it to you. Let's take this relatively common, not that overly expensive capacitance meter. Believe me, I've got way more expensive ones. And yes, I understand that this wire is going to add inductor to it, which is going to make this read a little bit false. But the idea is here. This fully interleaved is 48 picofarad. Now watch. $36. $28. Okay, that's 28 picofarad. Or puff. Let me recrop this. So watch. We'll slide this back in now. Back to 53. Slide it back out. 37. So your adjustment window that we're wanting to hit within is going to be from 50 to, I'd say, about 25, roughly. Okay. That process of sliding this in and out is what we're doing internally on this guy. How's this work, BBI? Well, here is what is this? United Electric Company, made in the United States. This is a 50 puff fixed vacuum blocker. And the reason I have this out is because it is clear and we can see inside of it. you can use a clear vacuum variable. This is glass. This is ceramic glass. This is just regular Pyrex glass, ceramic glass. So I say clear or glass vacuum. These are both technically glass. This is ceramic. The seals on this are a whole lot more robust than the seals on this. I'm here to tell you. That's why if you're going to mount this up on top of your antenna and you're going to put it out in the elements, because it is kind of going to be exposed to the elements, you want to stay away from using glass. But you can use glass, you just got to support it really well and it eventually will crack and break. Okay? There are two tubes in here. Tube A goes into tube B, female, male. All right. This here is the female side. And here, there is a gear drive and a reduction and a whole bunch of set of rings, a bunch of round circular rings. And they feed inside each other. They slip inside of each other. As we turn this, it slowly inserts, like in here, slowly inserts the shaft inside of here. Remind you of anything else that we're talking about? When I explain to people how to build this, it's really super simple. We're going to hook up our coax here and we're going to hook up our antenna on this side with the tuning rod. This is the tuning rod. That's your coupling tube. Well, it's the exact same principle that's going on here. It's just not vacuum. Okay, visual demonstration portion of this over. Let me show you operation principle here. So we're going to hook onto the bottom of our vacuum tuner. We are going to hook onto the top of our vacuum tuner. And right now we're at about 120 something puff. Let's come around over here. Let's start turning our knob. Okay, so when we turn the capacitor this way, we're adding capacitance. Otherwise, the plates are dropping down inside of each other and they're interleaving. So now we're going to turn it clockwise. Oh, capacitance is coming off. 123, 104, 80, 63, and so you can make really minute adjustments with this. 56, 71. The refresh rate on this thing is really slow, and as I bring my hand close to this, it changes the capacitance. But the point is that we can take it really low. Remember that this thing fully extended was about 27, 30 something puff, right? 22, 20, 15, 16, 14. Let's bring this on up to about 50 and we're going to leave it alone. Remember, counterclockwise is more. It means screwing down and bringing together is counterclockwise. Clockwise is less. If I was a betting man, I bet you my buddy Lee's feed point is going to turn out to be something around 45 puff. So we're going to leave that right there. This vacuum variable is like uber overkill for you. Uber. 5K, 6K, somewhere in there is going to hold a whole lot of jam for you. I mean, like easily carry a couple sixes. So you can use a much smaller vacuum variable, and it doesn't have to be this long. I mean, it could be that long and that big around, okay? The whole idea behind this is we're going to set this over here for us to just keep in the background as a visual idea of what we're doing. Is that we're going to replace this mechanical device with this mechanical device. Vacuum is the ultimate insulator. It is. Nothing has a lower dielectric. Dielectric properties is a very fancy way of saying insulation, or the ability to resist conducting energy. Okay, vacuum is like the ultimate thing. Teflon is pretty high up there too. It's not too far behind vacuum, but vacuum is really superior by a lot. So instead of using a physical, because there's a physical mass here that's acting as an insulator, we're going to use vacuum. Okay. The idea is that we're going to mount this in some kind of device that allows this to stay static and not get whipped around or banged around up on our antenna. It's going to be somewhat guarded from the elements, and we're going to protect it, and then allows us to hold everything in place. Now, I was in a situation one time where I was working with some 7/8 heliacs. We brought the 7/8 heliacs directly to the back of the vacuum variable. Then we took the tuning tube, the shorting bar, literally folded it over, bolted it to the end of the vacuum variable, and then tied the thing with mule tape, where we were suspending this off the, we'll say here's our element. We were suspending this off the element with tape, and then we took plastic and put it over the top so water could run over it. It was, the guy went back and redid it. The point was that the whole idea was to just suspend this underneath the element and keep it so that it's fixed, okay? So what I'm gonna use for that substrate construct is gonna be PVC, white PVC. The PVC will last about 10 years. ABS will last about maybe 12. Okay, there's not a lot of torque load, there's not a lot of heat. The only thing you got to worry about is the UV light breaking it down. Now, most PVC pipe that is black, the dye that they use to make the plastic black, is conductive. So I strongly suggest, and I know this from personal failure because I like everything black. The first one of these I built, yes, I built it inside of a piece of black PVC, and it fucking arced all over the place. It would. The dye that was in that specific PVC was very conductive. You could use Dalron tubing. There's a lot of different ways that you can go about doing this. There's a lot of different ways to skin the cat. The whole idea is to put this in place of this tube. And this shorting bar, instead of it mechanically moving, you physically moving, it stays fixed, and the only thing that you're adjusting is here. The principles stay the same. We attach, we're going to use this piece of 1/4-inch tube, or 1/2-inch tube. We're going to physically attach it here on this end of the vacuum variable, and your coax attaches here. Every time I try to explain this to somebody on the phone, they're like, I don't get it. Can you send me pictures? Yes, I have pictures in my phone that I send pictures. Here, this is how you do it. I built one of these step by step. This is how you do it. And I would have sworn I did a YouTube video on this. I guess not. I must have put it on Facebook or something. So I thought I'd come out here and I'd make it available for all of you guys on YouTube. You're going to need one end cap, another end cap, and 2 fiberglass. I prefer fiberglass. You can use plexiglass, you could use Lexan, you could use Dalron once again, you could use Teflon sheet. There's a lot of different ways to skin this. I prefer fiberglass. It has a tendency to last long. It's like plexiglass will last for a couple years, and then the heat and being out there in the elements, it'll crack, shatter, break, and become brittle. We've all dealt with it with antennas. I prefer red fiberglass. This has a tendency to hold up with more voltage. I'm not gonna lie, the one that I'm currently using has got just regular tan, high voltage fiberglass. It has to be thick enough to be able to support the weight of the vacuum tuner. The idea is to get this tuner spaced evenly on the inside of this and support it from the bottom. You want all the weight to be cradled on the bottom, but you want to leave the top portion of the tuner available for us to make our physical connections to. Physical connections. You do not want to use the fiberglass as a sandwich to physically attach anything to anything. You want metal to metal, and you don't want to have, like, let's say we're going to use this plate and then attach on this side. Because what are we creating when we do that? A capacitor. There's a gap, and there's going to be a capacitance value that takes place here by us putting a bolt through here and then having our eyelet attach on this side, let's say. That little gap is capacitors. Now you're building a capacitor. You want to have a physical connection directly to the cap. So the best way to do this is to create, like in this situation, I got little half moons. This will bolt to this bolts to that, this bolts to that, so we can attach up here, our physical connection, attach up here, and our cap will be suspended, perfectly happy, living inside of here. For this particular vacuum tuner, I'm using a 14-inch piece of PVC, white PVC. Off this end, we're going to create our bracket for us to be able to mount up to our antenna. So I have a little piece of aluminum that attaches here past the cap point. That cap goes on. I have a little piece of aluminum that attaches here, rises up, and kicks over and goes back to the boom. So you can take a U-bolt or attach it to the whatever. Attach this to the boom to keep our spacing even. The same thing that's going on here. Okay. I have another cap on the other end. It'll have a hole in it. This rod goes through it, but in the same breath in here on the inside, we're going to have holes drilled through this. There's going to be a mechanical connection in here, usually some like 632 screws that are stainless, going through and physically making the connection between this tube, and then we're going to use a flat piece of copper to go from the tube down to the vacuum tuner. This side is a little different. We're going to show you how we couple that up. Some things to think about. Words of wisdom to live and rock by, I guess. This thing will get moisture in it. It's not a matter of if, it's a matter of when and how you go about managing it. Do not seal this. Do not seal this. Leave it open. And what I mean by open is drill a series of holes across the bottom of this thing, and you want to have the holes so they're orientated straight down. So if moisture gets inside the tube, it can come out of the tube. And as temperature changes, and there's going to be a little bit of moisture inside this tube no matter what you do, it can evaporate in and come out. Okay, next little tip. Make the holes small enough that bees, wasps, and other frickin' insects cannot get in here and make themselves a home. I had a friend of mine. He put big openings in this thing. It was like big. It worked for him for like 5 years, and all of a sudden his SWR started creeping up, and then every once in a while it'd just arc over hard, but then it'd go away. What has happened is wasps had decided to build a home inside of this tube, and every once in a while they'd build the home over to the point where there was enough shit mass on the inside of this thing to where this connected over to here, the RF would burn it away, and then he'd get his insulation property back. But when he went up there to figure out what the hell was going on, he had himself a hell of a mess going on. Wasps flying at him and all kinds of crazy shit. I've seen guys where they build little brackets for these. They'll suspend this on the bracket, and then they'll take a piece of very thin ABS plastic and they'll fold it around the element, and the vacuum tuner, and just leave the whole bottom side of it open. You can do that if you want. Like I said, there's many different ways to skin a cat. This is just the way I've found that works best for me. Good? Good. Last trick and tip. If you forget to drill your holes in your tube, don't be like one of the guys that was here in town. When I heard this story about, fell out of my chair laughing. Vacuum tuners are expensive. They're getting more expensive by the day. By the way, I strongly suggest that you go make your vacuum variable purchases from a tested, trusted source, and that's Max Gain Systems. I'll put it right up here in the, not paid by this guy, just I know Alan and he's a good guy. He high pot tests everything, vacuum tests everything. He's a good dude. Go to Max Gain Systems to buy your vacuum variable if you can't find them at Hamfest. Just saying. Do not have this whole thing assembled and put up on your tower or on your vertical antenna, because yes, you can use this if you have that kind of system. on your vertical, you can replace it with a vacuum cap and increase the amount of horsepower you put to the antenna dramatically. Do not decide after the fact that you're going to drill drain holes in the bottom of the tube because you forgot it in the step, and you're going to be like, oh no, I'll be real careful. Dink. You've just now shattered into your glass. Broke the seal on your vacuum tuner, and it's done. Time to start over. I have not made this mistake myself, but I know one guy here in town and 2 other people across the country that have shared this mistake with me. And I'm like, well, yeah, that's a mistake. You do this pre-assembly, not post. If you forget this step, take the whole thing apart, go to screw, and then put the whole thing back together. Save yourself the heartache. Okay, let's build this thing. Okay, so now what I did here is this is our output side. I created a template that matched up with all the mounting holes, and then I put slots in them so I can adjust this back and forth for square. That makes sense? So all we're going to do is we're going to put the hardware in, which is going to be, and remember, we've got to make this so it's anti-vibration, right? So that means we're going to use a lot of stuff like lock washers and Loctite in the assemblage of this because we don't want it coming apart. We don't want it coming apart. We want this to be able to go up there and stay up there for a while and not vibrate apart. Well, there's no electrical properties to this, but I want the vacuum tuner to be in place and not get the shit beat out of it. So we're going to use, I believe, 832. Yeah, 832. We're going to use a little lock washer and then a regular washer, Phillips head screwdriver, and we're going to thread this in. One thing I did not mention is that I went through and I put a little dab of oil in each one of these mounting points, each one of the thread pockets. So that way we don't have to worry about in the future there being any kind of dissimilar metal corrosion, because that might be a thing. But unless you live, well, I'm basically sending this to a swamp, like my guy here in Hawaii, you know, there's going to be moisture that gets in here. Just something to think about, something to think about, something to think about. Okay. Okay, so that fun little bit's done. Got our spacing plates all mounted up. And less capacitance, more capacitance, of course. Backer plate all mounted up. And what we've created here are these 2 copper tabs, and there's no difference in doing this. Okay? But we're spreading out the surface area. This works. I've had it not work so hot. This is a piece of 218, and the eyelet was about 4 times this size when it started. That's the center conductor. Melted down, okay? And eventually came apart. Of course, then I was putting 4 or 5 watts to that. I wasn't, you know, wasn't doing 1 or 2 watts, it was 4 or 5. Wink, wink. Anyhow, so I went to this system and I spread it out using big copper plate, lots of contact surface area. Okay. And then the other thing I'm going to do, and I'm going to do with this one, and I did with my own, and I've done in the past, and it's worked out well, is we take the connection outside of the tube. I'm going to show you what I mean by that. We're going to feed this with a piece of 4 gauge in here. So we're going to bend this down, and then we're going to make a little hoopy thing, and then we're going to put this in it, and then we're going to solder to it. So there's no chance of physically coming apart. And then outside the tube on the other end of the 4 gauge, we're going to put this big, thick, heavy eyelet, and then he can bring his, you know, 7/8 or whatever he's got, bring it directly to the center conductor, bring it directly to this, and make an eyelet on the end of that with the center conductor, and then use a bolt and big stainless steel hardware to bolt this together. It's a whole lot easier working outside of this tube to make that connection than it is to have it inside the tube and you trying to balance everything up on top of the tower in a bucket truck or whatever. Just Take it outside, have a little bit extra inductor on the damn thing. It ain't gonna kill nobody. To where you can work on it outside. Makes it a lot easier. So now what we're gonna do is we're gonna get all of our spacing set up. So we're gonna make it so that this slides down inside of here. So we'll probably take and I'll lay a screwdriver across here, and I'm gonna make a nice smooth bend. And the same thing here, nice smooth bend. No hard 90 degrees. It's bad. RF don't like hard 90 degrees. You want smooth bends. We're gonna make it so we slide inside of here, and we're gonna start talking to ourselves about doing this. So let's get this inside of here, and let's get this mounted up back here and connected on the back side of this thing. And then we'll talk about putting our Hako strain relief that comes out of the side of this that allows us to go to our coax, and we'll start getting our holes drilled up for our mounting for this. Smooth bend. Smooth bend. Once again, no hard 90 degrees. Rounded. Okay. This lays inside of here, and lays inside of here. It's all supported and solid and safe, and it's not moving. Now, we're going to trim this down quite a ways. So this is going to sit inside of here probably, say roughly like so. This will get trimmed back to here. So I'll probably keep bending this down a little bit further. I'll just bring my 4 gauge right into here and solder it so it can sit a little bit farther forward. That way we still got room for our mounting and our end cap. But you starting to see where we're going here? Once you guys see this, you're like, oh God, it's so simple. There you go. Exactly. This is such overkill. So I went ahead and I got Brunhilde off the shelf. That's 16 or 1900 watt soldering iron. This has taken 45 minutes to get up to temperature just to do this one solder joint, because my little 150 or 100 water wouldn't, or 150 wouldn't quite cut the mustard. I get tired of dicking around with things. Let's see here. We're at 536 degrees at the tip right now. Stupid overkill. The whole way I'm building this is just silly overkill, but it's to get the point across. I got to solder this joint right here, and it's got to be, I mean, I took and rolled the copper over like I was creating an eyelet and pinched it. So we've got a hydraulic fitting, like a pressure fit, but I want this to be electrically schmoo-glued together, right? Super overkill. I went ahead and I built the rest of this out. This is where our actual shorting bars, or tuning bar is going to go. This is our end cap. I went ahead and marked this so he'd know which way to turn it. As we all know, these cups are actually tapered. So if you go down past this ring, I got it marked here with this Sharpie line. If you put the cup on down past the ring, God help you if you're going to be able to get that off. I mean, you're going to have to be up there beating on it with a hammer, which is not very good for this thing. Went ahead and fabbed up the bracket, which bolts on the top. I'm going to give you this entire chunk of metal, bro. So you can bolt this here. You have to determine, I mean, you want to have like a 4-inch, 3 or 4 inch, probably 3.5 inch gap between your driven and this guy. And I don't know what you got going on. I think you said something like 3-inch boom or something over there. 4-inch boom, 3-inch boom. So you're going to bolt this on here. It's the only assembly that you're going to have to do. Well, that and put this tube on, because otherwise it's just too long to ship. But bolt this on here. You determine what your standoff needs to be from your tube, or from your boom, or from your driven. You're going to take and you're going to fold this over. Put this in your vise. I know you have it. I know you have these mad fabrication skills, so fold it over. This is thick enough gauge aluminum to be able to easily support the weight of this tuner in the tube and everything. Fold this over. Now, in most common practices, we're used to having this thing hang straight below the driven. Well, our vacuum tuner is such that it's going to hang more or less off to the side. So if this is our driven element, it's going to sit something like this. Something like that. And not directly over the top. Or like, you know, it's going to sit just like this. Just a hair out in front. And that's fine. You just move your shorting bar. Instead of having it come straight down, it's going to be cocked back just a little bit. It doesn't matter. It doesn't change the electrical processes at all. Got this drilled out, got this all drilled out, got the washers for it. I'm going to show you how that all goes together. Got this all drilled out for mounting. I'm going to show you how that goes together. But really, I want to make sure I get this. Let's get in here. Sorry, camera's going to jerk around a little bit. I got to turn my monitor around so I can see what the hell I'm doing here. Okay. Good old Brunhilde. All right. There it goes. Flow, big girl. There it goes. There, that ain't gonna come apart no way, no how. All right. So that's what I was looking for, was complete through solder, and I was not going to use a torch. So no sharp edges, rolled, good mount. Okay. So now what we get to do is we're going to squeak this thing into here. And then I'm going to take this back nut for the strainer leaf. I went preloaded on the wire. Slide this inside, take the wire, hook it out the hole. Out of the hole. Okay, take our strainer leaf. Nope, little rubber washer's pretty important there, strainer leaf. Kind of start that on there just to hold it in place. And then we're going to get our Hako installed, which, because this is a bent surface, we're only going to get a couple thread turns on it, but that's all right. That's all we need. Don't want to tighten down that wire yet. Rotate this into place. First washer. It's a constant exposure. This workbench is so bright. Slide her in the goody hole. Poke her in the doody-o. Okay. All right, so now we're gonna get our hemos. Hemo's steaming the nose, and we're gonna tighten this down. So here's the end of this. So you can see the inside of it. 4 gauge just comes down, goes right through the strain relief. The marine grade heat shrink is UV rated. Hydraulically crimped and soldered the eyelet here. So just take your bracket. I'll provide you some hardware. I'll throw them in a little bag. Bolt this up. Figure out where your 90-degree bend needs to be. Take this straight back, bolt it to the boom. What most guys do is they'll create themselves a whip or a pigtail on the end of their coax, and they'll just bring the end of the coax down, the center conductor and the insulator, and they'll bring it right down to here. Bolt the two together with big heavy-duty stainless steel nut bolts and washers. Don't put an eyelet on your center conductor. Make a loop out of it. Bolt it directly to this. Then you're going to cover this whole thing from here all the way back up to the shield where the shield bonds to the boom with electrical tape. And then you're going to put butyl on that and then another layer of electrical tape. Because you want to keep water out of this joint, you want to keep water out of your coax, obviously, and you want to provide UV light protection. Please note how I have these washers spaced. That's for a reason. That's to help support the weight of the vacuum variable. But this is... that vacuum tuner is in there very well supported. Once again, we got the same marked lines on it. You put that cap on there about that far, it ain't never going to come off. And when you get this set up appropriately, your boom's going to come right by the end of this anyhow. So you want to set your gap up so you can just, and I mean just barely, with you forcing it, you'll be able to get this cap to clear the boom. Walk that in, there'll be about that much gap between the boom and the end of the tube. Down here on this end, of course, we put a little rubber washer here on this end. And the cap will just be able to hang free. Then on the inside, it's got a road map here for you to see less and more capacitance. And this is what it ended up looking like down the inside of this thing. Lots of surface area is the goal. Lots of surface contact, lots of pressure points, not just one, but multiples. Spread it out, surface contact. So if you can envision working on this thing, you'd be hanging up there on the tower and you're like, wait a minute, which direction do I turn it to get more and less capacitance? There you go. Well, gentlemen, that's it. That is how you build a vacuum variable. And I thought I'd do a video like this to demonstrate how to get her done. Because when you go in to push this into the old Googler, what you get is a couple rare old posts from back in 2002 from like Mall Droppers or something. And then they'll mention some dude, but they don't give no contact information. They don't discuss how to build it. They don't talk about nothing. I thought I'd give you guys a ballpark where to start. Keep in mind these two tubes are electrically the same length. It's a 24-inch tube or 24-inch rod from here to here. This is also 24 inches long. You'll find that your shorting bar is going to be somewhere about in here, 10 to 12 inches from the end of the tube, which oddly enough will end up being right about in there. You can actually end up lopping some of this off if you want to. Take the last 6 inches off. The last thing you want to do is, of course, on the tip, just the tip, baby. You're going to fill that in with silicone. Just put a little dab of silicone in there. Help keep the bees out, because if this gets water in it, it'll run out the inside. You don't want to seal that up. But this will come to you with this disattached, but the rest of this will be all assembled. The hardware will be here to help hold the vacuum variable in place. And of course, there'll be foam on the inside of this thing. So that's it. How to build your own vacuum variable feed point 101. Gentlemen, once again, if you can help me out in any way, come down here, come to Patreon/BBI Amps. Come join us. There's a ton of Patreon exclusive content. Every project I work on gets a lead video that goes up. It's on YouTube that none of you guys on YouTube land get to see, where I talk more in depth about a lot of the things that I'm working on. Lots of behind the scenes stuff. Come join us. It's just another avenue. And as always, Facebook, BBI Amps, the group, and the webpage, www.bbiamps.com. Gentlemen, thank you. I appreciate every single one of you guys. If there's something here that you feel like you need to talk with me about, don't hesitate to give me a call. That's what I'm here for. That's what all of the other fellow Patrons help pay for. It's for me to sit for 3 to 5 hours a day and talk to everybody on the phone. So, got a question, something you need to talk to me about this or any other project you got going on, give me a shout. Gentlemen, I'll see you, and thank you from the bottom of my heart. Bye-bye.